Right. Thank you for attending the paper 5 seminar. Right. So we have seen the question. You have I hope you have downloaded the question paper. Right. So this is the question for those who are not having the question paper. Now, as you know, paper 5 is 1 hour and 15 minutes. Okay. 1 hour and 15 minutes. There are 2 questions. Total mark is 30. And the typical score for paper 3, the typical score, if you look at the score or the threshold grade for this paper, what is it? So the threshold grade is 21, right? The threshold grade is 21, as you can see here, right? Now, according to the examiner report, most of the time students score average mark of 9 or 10 for question 1. Okay, 9 or 10, which is not good, right? Because question 2 is out of 15. If you do the bare minimum, you might get 12 or 13. Okay, hence you have around 21 to 22. This is, I'm talking about maximum mark some students they score. Right, so why they are not able to score more than 10? That's why we are having this seminar. I'm going to focus mainly on question 1. Question 2, I leave out as Q&A. We're going to discuss a particular method that will be used for question 1. Right? Now, let me ask you something. Were you given a scribbling paper in the paper 4 exam? I think most of the exam, they give you a scribbling paper. Correct? Yes, very good. So we're going to use the scribbling paper to plan out for question 1. Right? And this is the question. Now, most of the time, when I mark the students' paper, right? What I notice is that the reason why they are not scoring mark is the additional detail, number 1. Okay? If you look at the mark scheme for this paper, right? For the identifying the variables, it is given 2 marks. Okay? For the method or procedure, it is given 4 marks. For the analysis, is given 3 marks. And for the additional detail is 6 marks. That's a lot. And remember, I told you, most of the time, the examiners or the average mark scored by students is around 9. The reason, because not much of additional detail. Not only that, okay, 1 mark for the diagram, most of the time students don't score the diagram. Okay. The reason is because most of the time students start with the diagram, because that is the first thing that you see under the space to answer. Okay, to write your answers or write your procedures and method and whatever. You see the diagram, you wanted to fill up the space with drawing. Okay, now my advice is that you don't draw it out first. Okay, don't draw the diagram, don't draw anything until you finish writing the procedure. Okay, until you finish writing the whole procedure. Okay, right? You draw the diagram later. The reason because if you draw the diagram first, that is the first thing, your first idea you have. Okay, you draw the diagram, done, and so on. When you start to write, ideas and ideas after ideas, point after points will pop up in your mind. New ideas will merge as you write. Okay, I should put this, I should put that. Okay, right? Maybe you draw a circuit diagram and then you forgot to put a variable resistor. What are you going to do? You're going to erase the diagram. Okay, you're going to put a variable resistor. Right? Or if it's a heating experiment, you forgot to put the insulator. Now you're going to draw the diagram, you're going to erase it out. So all this is going to now make the diagram, okay, look improper. Or sometimes you might forget. All right, certain things when you write, you forget to represent in the diagram. So it's best that you draw the diagram later. As you draw, you will remember your procedures. You want it to be represented on the diagram because that's the first thing the examiner is going to see. Okay, the diagram must be workable, something that when someone read your script, okay, he or she able to reproduce the experiment. This is the whole purpose of paper 5. It's a scientific, you're writing a scientific report. Okay, you're writing a scientific procedure, how an experiment is conducted to verify a particular relationship. All right. So in your write-up, this scientific report, if you're going to put a diagram, to represent how the experiment is done, the person who's reading it, when he or she reproduce the apparatus, meaning that rearrange or set up the experimental all the apparatus according to what you have given there, and the experiment can be conducted. Simple as that. That's the whole purpose. Right? Number one. Number two, the diagram that you draw, the experimental setup must be workable. What does it mean? Meaning, okay, if let's say he or she now, right, arrange the apparatus as how you have shown, he or she must able to get the results according to what you have written. So you must have that in back of your mind when drawing the diagram. That's why I say you draw the diagram after you write. You write everything, then you draw. All right? The diagram has to be two-dimensional, not three-dimensional. Okay? For example, if you want to draw, let's say, on a table, no need to draw the table three-dimensional. Okay? You're not sitting for architect exam here, all right? And then you're drawing for example, the waving balance, okay? All three-dimensional. And then you're putting the beaker, okay? Something like this, not necessary. No, you don't draw this way, right? Make sure it is the table, okay, like that. That's it. And then we have a waving balance, and then a beaker, and label it. Right? So make sure the apparatus is not floating around, right? If you're going to put a thermometer, the thermometer is not going to stick like that. So you need to put a retort stand, right? You need to put a retort stand to hold the thermometer. For example, this experiment is something related to heat. Don't put a thermometer just hanging around, right? Remember, I told you this is about scientific report. So another person, physics student, is going to do the experiment, wonder, how am I going to put the thermometer inside the beaker? How am I going to hold it? So if you put a retort stand, then the student will know, okay, with a retort stand and so on. Now, how about circuit diagram? The circuit diagram you can draw as a schematic diagram. Okay, schematic diagram. Do you know what's a schematic diagram? Okay, let's say like that, power supply, okay, variable resistor, emitter, right? Okay, let's say this is a heating element, okay, heating element, and so on is the voltmeter. This is schematic diagram. You can label that schematic diagram for this, right? Maybe you put a heating element here, okay, and then, right, emitter here, okay, goes through a power supply. This is also good enough. This is also fine. Okay, variable resistor, and then the voltmeter, right? Voltmeter like that. This is okay. This is also fine. You can label this as a schematic diagram, or you can show this separately. Okay. So this is how a diagram should be drawn. Two-dimensional label. Label all the apparatus that you're using like this. Don't label one is like this with a curved line, then one is going like that, one is going like this, one is going like this. No, all straight line. Okay, like this, heating element, straight line. Okay, and label it. Right. This is what I noticed when I mark some of your friends' paper. Okay, as I mark, all right, I noticed that the diagram can be further improved. Okay. Now, coming back to this question, how do we answer? So most of the time you get a format. The question will have this particular format, right? They give you some sort of diagram here. And then straight away they give you a formula, okay? Where the formula has a couple of physical quantities, which you need to identify which one is the variable, independent, dependent, and the constants. Okay, most of the time the experiment have more than one constant, right? And that's where students also lose mark under additional detail. They don't identify other constants, okay? Right, sometimes the experiment has more than 2 or 3 constants, which enable you to score marks for additional detail, which you see in this particular question, right? And then the most important thing is that they say that design a laboratory experiment to test the relationship between T and R, time and the resistance, and use your results to determine the value of K. This is also what students missed out, especially under analysis. How do you find K? How is it related to the graph that you have plotted? Okay, keyword. Now, I would not pay attention to this part. Let me tell you why. If you start answering according to this, the procedure, measurement, control variable, analysis, any safety precaution, you are going to score only the bare minimum mark, most probably not more than 9 or 10. Okay? Because did they say that you need to list out any additional detail here? Did they say write any additional detail? No. But you know that additional details cost 6 marks for this paper, but they didn't list out that. Okay? They didn't say anything about that. So you don't try to answer according to this directly. Okay? Right? you can try to follow the particular method that I've been using to train my students on this particular, to answer question 1. Okay, so now I hope you have seen the question. Okay, let's get. Right, so I want you to take a piece of paper, right? A4 paper. Imagine this is your scribbling paper. Don't go and take the scribbling paper that you for the last exam, you're supposed to not have any scribbling paper. That's what I'm talking about. Imagine this is a scribbling paper that you get when during the exam. Okay. Okay, I'm going to draw some a simple table here. Okay. So first, we're going to identify the variables. Okay, then we have the procedure. So procedure, what you need is we need to identify the correct measuring tools. That is very important, right? Then the measuring technique. Measuring technique. Right? And then we have the additional detail. There you go. Right? Then we have safety. And the last one is analysis. Now, I'm not asking you to do this during the exam. You have 1 hour, 15 minutes. I'm not asking you to draw the table. That's up to you whether you want to do it or not, because you know you can submit the scribbling paper. You can put the scribbling paper in the paper 5, in the booklet, like what you did, some of you did for paper 4 or even for your AS exam. You can do that if you want, right? So it's not a waste. It's not a waste of time. But if you have all these points written like this, you will have all the required point to match the mark scheme, especially additional detail, right? If you're going to just scribble, like writing an essay, right? Write the important points, you might miss out some of the points. Okay, so variables, as I told you, there are 3. So we have the independent variable, then we have the dependent variable, then we have the constants. Constant, I'm going to put 1, 2, 3. I do not know how many constants are there in this experiment. I do not know, not yet. I'm just going to put 3, just kind of forcing me to come up with some points if we have. I know that immediately when I put 1, 2, 3, I know that, oh, definitely there are some constants other than the main one, all right? Okay, so I'm going to write the marks roughly because it's almost the same for the last 2, 3 years. So here is 2 marks. Here is 4 marks. So as a guidance, right? Additional detail, 6 marks. Analysis, 3 marks. Okay, additional detail and safety is 6 marks. It comes under that. Okay, what do you think you'll start off first? Which one you'll do? Can you write on the chat box which one you'll start doing? Not the wrong variable, but then you might get the variable swap. Okay, so we don't want that. So the formula given, T equals to Kn squared A LR. This is the formula given. Okay, T equals to Kn squared A LR. So N is the number of turns number of turns, A is the cross-sectional area, R is the resistance, L is the length, T is the time, and what is K? Did they say anything about K? All right, K we just assume is some sort of constant, right? Right, I'm writing it down for my reference. All right. So we compare this equation with y equals to mx plus c. Right. And here in the question, they said that design a laboratory experiment to test the relationship between T and R. Right. So the student is investigates the current in the coil and the resistor connector. The student connects to a high voltage power supply and a switch across the series combination. When the switch is closed, it takes time t current in the resistor of resistance R to reach a maximum value. So the T depends on the R. When the R reaches a maximum value, that means it's not something instantaneous. Right? It takes a particular time. Right? Is the reason because, of course, we are not going to super analyze the experiment. It's just to know what's happening. The current which is passing through a coil, and whenever you have a coil, remember the filament light bulb coil, the resistance builds up. Okay, resistance builds up to a particular value, or what we call optimum value. Normal light bulb, that's how it works. So it's a similar concept, right? It's not instantaneous. It builds up the resistance, so it takes some time, right? Now, the thing is that you have to have a mind thinking is that the time is how do you measure? Do we measure using a stopwatch? Is it short, very, very short, or is it a very long? Okay, we need to think, right? The time, is it measurable or not? Right? It's using a stopwatch, or do we need to use some other method? So we compare with these. So there is no y-intercept, C. So therefore, y equals to mx. So the moment you compare, you know already that T is the dependent, okay? Kn squared A over L times 1 over R. So this is the gradient, M. Right? So this is the gradient M. So therefore, we can write here, right? So Y, M, X. So immediately we can say that the independent is resistance R. The dependent is the time, T. Okay, constant. Let's look at the constant. See, this is where we identify. Okay, what we have, the constant is N, number of turns. Number of turns. Second one is the cross-sectional area, and the third one is length. See, this is why I asked you to do this method. Right, before you do this, so we can identify all the important variables. Okay, once you have done this, now we can know what graph. Draw graph T versus 1 over R. Now, if I'm you, I will draw out T versus 1 over R like this. And what is the expected graph? This is the expected graph, right? And I can say that the gradient is equals to Kn squared A over L. And remember the question asking you to find out the value of K. Therefore, K is, right, gradient times L over N squared times A. And the most important is that from the graph, we can say the relationship is valid if the above graph is obtained. You can write like that. If you don't want, then you can state a graph, a straight line, graph through a straight line through origin. Graph is obtained. So here you score, right? How many marks? This one definitely A1. That's 1 mark for analysis. This is 1 mark for analysis. Another mark drawing the correct graph, A1. So you already score 3 marks. There you go. You know already. If you do this, you score already. Okay. Now, when you do this, psychologically, you are more confident. You know what to write. You know you have identified correctly. Okay. And you're halfway through. Right. So this is the reason why I asked you to do the analysis, something that most of you all can do. Right. And most of the papers I marked, I would say 85% of the students can do all this, can score. Right. Mark totally for an identified. Okay, and with that, you have identified the independent, dependent, and constants. See, this is where you score mark, right? So what are the measuring tools for resistance? How do you measure resistance in the circuit? Right, so we know that it has a resistance like this, and then we have a coil. So it definitely needs some sort of circuit. So how do we find out the resistance? So we need to put an ammeter and we put a voltmeter. Okay. So measuring tool, voltmeter, all right, parallel connection. You can explain or you can draw it out. Ammeter in series. All right. And measuring technique, what are we finding here? Resistance using the formula VOI. Okay. So what are the additional detail? We are measuring resistance using electrical meter, right? So we need to repeat measurement for V and I and take average. So you go like this, filling up each of the blank. Safety, we are using electrical. We are, since we are dealing with electrical instrumentation, right? We need to wear insulated glove to prevent electric shock. Okay. And remember, there's some sort of heating involved here. It's not the main purpose of the experiment, but in whenever you are suggesting electrical instrumentation, which involve high voltage, high resistance, and there's some heating element, you always must suggest that, all right, switch off the circuit when not taking reading. This one actually comes here, right? Give a reason why to prevent overheating. Give a reason why. Oh, the other one, before I forget, okay, gloves. You guys are went through the pandemic. I'm very sure you know the importance of glove, but we are only wearing one type of glove. That's the latex glove. That's to prevent maybe the transmission of the virus and whatever not. But you can't go and wear that kind of glove when you're dealing with heat or high temperature. The latex glove is going to melt and you'll be part of the latex glove. You need to identify the correct glove. Okay. Number one, for heat related, you can say heat resistance glove. All right. If it's a radioactive material, you're dealing with radioactive material, you need to hold the radioactive material. Then we use lead line glove. Okay. If it's a prevent cut, sharp object. Okay. There are some experiment where you are dealing with glass sheet or metal sheet. Okay. Sharp edges wire. You may want to put cut resistance glove. Okay. And few other type of glove maybe you can come across, you can suggest. Okay. So these are type of gloves. Make sure you be a bit more specific. Now, dependent is the time. How do we measure time? In this experiment, the time is going to be very short. Okay. Time is short. So we can't use stopwatch. The best method is using CRO, cathode ray oscilloscope. But then whenever you suggest cathode ray oscilloscope, you must explain how to analyze it. How to analyze it. All right. Don't just say cathode ray oscilloscope. Cathode ray oscilloscope doesn't give you the reading. You have to analyze it by looking at the time base and the voltage gain and whatever not. You have to analyze it. So you need to explain how do you find the time. Okay. Right. Let's say you start at this point and then the value goes up. Okay. Goes up like that. It will go up. The resistance goes up. So you're finding the time, right? Maybe the point you start and the point you're taking the reading, okay? And then the time base times X, okay? Times X, you get the time, right? It's the setting of the time base times how long it takes to get the particular reading. Huh? So on the CRO, you'll notice that the CRO has like this, right? So this, the x-axis is the time base. So if the graph, you start point here, it goes up. Okay, this is the time left. So 3 boxes or 3 division time times the time base setting. Example, maybe it is 10 milliseconds per division. Therefore, it's 30 milliseconds. Okay, that's how you explain, right? This all it carries a lot of mark. Right? Not only that, if the time is too short, let's look at the formula. If the time is too short, how do we increase the time? Can you write on the chat box? How do I increase the time? Can you suggest? If you look at this time inversely proportional to length. So you can suggest here, okay, under additional detail, we can suggest that to increase T, use, okay, shorter length, you increase the number of turns, smaller resistance, okay, and remember, R equals to VOI. You can also use a large current. This also scores mark. All right. Now, once you have identified the constant number of turns, all right. Okay, so keep the number of turns constant. Cross-sectional area. What is this cross-sectional area? What are they referring? Cross-sectional area of the coil. So how are you going to measure the cross-sectional area? We're going to use micrometer screw gauge. Now, the moment you are using a sensitive tool, micrometer screw gauge and vernier caliper immediately you must say repeat. Okay, repeat the measurement. And don't say just repeat the measurement. You have to say and take average. And how do you take the area? The micrometer screw gauge is not going to give you area. You have to write down the formula. Okay, A equals to pi d squared over 4. You need to write down the formula. And it's a coil of wire. You have to take the diameter at different position. That also need to explain. Length using vernier caliper or meter rule. Again, repeat the reading. Okay, so these are all the information you need to write up. I'm not asking you to write like this, but you write down in a point form. I'm not asking you to write like full sentence. This is just for today's workshop, right? I'm asking you to write in point form. At least you fill up all the empty space here, all right? With your points, you have the mark. Okay, let's see how the marks are awarded. All right, normally for the variable, the independent and dependent, it carries 1 mark if you identify correctly. One of it is wrong, you would not get this mark. Constant, this carries 1 mark, P1. So variables, you have that. How about these two? Okay, these two comes under additional detail, D1. Right? Measuring tool, you have identified the correct tool, M1. This is another mark, M1, for the CRO to find the time. And then this is another mark, measuring tool. Okay. Right. Where do you think another mark goes? For the diagram, right? For the diagram, you score 1 mark, right? As I explained just now, you have to draw the diagram label. So 4 marks. Okay, so this is done. All right. Analysis, we mentioned already. How about here, 6 marks? You already score 1 mark here. See, by identifying the other constants. You already score 1 mark. Okay, so here you score another mark. Repeat the reading and take average, right? Don't say repeat reading. Must say repeat reading and take the average. And then this is another 1 mark. This is 1 mark. Okay, explanation about how do you analyze the CRO to find the time. Okay, 1 mark. Okay. And then how do you increase the time? You score another 1 mark. Right? And the formula to find out resistance, you score 1 mark. How many marks? 1, 2, 3, 4, 5, 6, 7. More than enough. Okay? More than enough. See? So you have like a checklist. All right? You have a checklist if you use this particular method. Okay, now I will